All right, friends, welcome to our second lecture, back-to-back lectures. I know this was a crazy week, so thank you guys for being here. Thank you for being a part of this. It is a little bit less slide heavy. I know that yesterday, a lot of you guys communicated that slides is not the best way you learn, but I think that it is really important to see something visually, not just going through code, but seeing just different visual pieces. And throughout this course, we're going to have different things that actually are explained better on a slide. So we will still have a mix, but this one is a lot more code heavy because that's what you guys asked for. Cool. So welcome. Today, we're really going to continue our Python fundamentals. Yesterday, we introed and talked a little bit about variables. We talked about all sorts of different things like lists and tuples and dictionaries, and we looked up how to look up different things. We're going to hit that again with the slicing and indexing piece, but we're really going to hit into for loops and functions. So that way you guys really have an understanding. We're going to write a couple, and then we're going to talk about return versus print when it comes to a function. Then we're going to do a code along, and we're going to introduce what we call packages in Python. You might also hear them as modules or libraries. So we're going to introduce those. We're going to introduce another one specifically for your assignments this week, and something we're going to continue to use. That's called NumPy. Or NumPy. I think it's technically NumPy for number in Python, but NumPy just sounds funny, and I really like saying it that way. So we're going to introduce those, and we're going to see how we're going to use that. And then we're going to jump into breakout groups, continue to use that, and then actually answer some questions that we have left out. As always, if we look, these slides are available. I do put those up. Slides are here. And then the Colab book, which we will be using today, is going to be here because you're going to have that for your questions. So make sure you do that. If you do want to edit that, again, just go through here, do file, save a copy in Drive, and that'll be your specific version of that because you can't, this is yesterday's, but because you can't edit my stuff. Cool. So those are there. And I do try to put those up as early as I can before class, but they are right there for you in case you do want to. Just as a reminder, this is our daily stack schedule. This just sort of tells you what's going on every single day, where the TAs are at, when they're there, has some hyperlinks to different things. We went in depth over this yesterday. So if you are a little bit confused by this stuff, I do talk about everything for the first 35 minutes of the lecture yesterday. So make sure you do watch that. If you weren't able to, just make sure at some point this week you do that. Again, as always, if you're not part of Discord, make sure that you are here. And if you haven't been part of Discord or you have no idea what I'm talking about, please let me know immediately. This is the main way we're going to communicate for class. Cool. With that being said, when Discord happens, if somebody has a question, let's say that one of your students, one of your fellow cohort mates is asking a question and you know the answer to it, or you just want to have some sort of communication of, yeah, I'm dealing with the same thing, I'm struggling. Here's what I've tried. What we ask is you don't reply, because that appears sort of on the main channel and it doesn't connect with the original message. Instead, we ask that you create a thread. And it's super simple. If somebody asks a question, you just go hover over it, and there's this pound sign that says new thread, and you can just name it whatever the question is. So if you're dealing with like NumPy, you just name it NumPy or something. But what it does is it allows us to sort of have everything in one thread. That way, and it's easier for you guys if you're like, oh, what was that one thing? I know we talked about it on Discord. I can't remember how to do it. It's all in one thread versus you trying to piece it up together. And it is easier for people to benefit to say, like, maybe, you know, you were off Discord and last night one of your students or a couple of the other cohort mates had a really great conversation on something you're not understanding. By having it as a thread, it allows you to sort of scroll through that versus, again, having to sort of find and piece it all together. As always, I just always want to remind you, core assignments are due Sundays. Make sure you double check your feedback document. I showed the feedback document yesterday. That is the only source of truth on if it needs to be resubmitted or not. So please make sure that you are checking your feedback document. I will remind you on Mondays and Wednesdays to check from the previous week's assignment. So next Monday, I'll say, hey, you know, I'm halfway through assignment grading, please check, et cetera, et cetera. So make sure that you guys are doing that. And this is what it'll look like. It will have your name on there. So right here, it'll have your name. and it'll have the status of that assignment. So if I'm saying missing, that means you didn't turn it in. If I say resubmit, that means, hey, you've turned it in, but there are some, maybe you didn't complete all the parts or you didn't do something correctly. I will put the feedback of what is wrong there. So if you didn't complete it, I'll say, please complete all parts. And then if you did something wrong, I'll say exactly what you did wrong. Or if it's passed, I will say, well done. So, and then, if there's something really great, I'll add some more feedback to it or something. Well done, but could have been more efficient this way. I'll do that. But that will be on this document only. As a reminder, you need 90% of your assignments to be the passed, not turned in, and then 4 of them are resubmitted. If that is the case, if you have multiple resubmits, more than one, if you've done every assignment, you have more than one resubmit, you still will, and you don't resubmit it, you still will need to retake the course. That is $500. I'm trying to be as upfront as I can, so that way nobody is confused by any sort of expectations here. Cool. Any questions on this core assignments, feedback document stuff? Again, just want to make sure I am as clear as I can, so that way there are no questions.
Yeah, well, I just tried to hit the link on the fundamental schedule for the Colab book. It says I need permission. Anybody else have that problem?
I'm also having that problem.
Yeah,
There you go.
that.
For which one?
For the lecture notes today on the or the Colab book today.
Yeah, collab for 223.
Mhm.
What page is that on?
On the Google Sheets.
Oh, on Google Sheets.
I had the same issue, but I noticed that I was logged into a different email account. So perhaps if you have multiple, switch it to the one that's connected to the dojo. That worked for me.
Oh, that was my fault. Here you go. There you go. You should today, Python fundamentals. Now you should be able to have access. Anyone with the link should be able to view.
Yep,
Sorry
I
That
have
about
works.
access
Thank
now.
you. Got
Yeah,
it.
sorry about that. Thanks for pointing that out. Really appreciate that.
Works. Thank you.
No problem.
Of course. Cool. Any questions on the core assignment stuff? Tanner, the link is in our stack schedule, but I will put it in the chat for you as well. And here's
I
the
can
link.
interject real quick too. What Will just did is what TAs are going to want you to do every time you send us your notebooks. Make sure anyone can view.
Thanks, Mandy. If you guys don't know, that is Mandy. Mandy is one of our TAs. Make sure you say welcome. She is here to help, helps a ton. She is brilliant. And then also is here to monitor the chat. So again, if you guys do have questions, you can put those in the chat and Mandy is here to help moderate that. Make sure your guys' questions are answered. Thanks, Mandy. Cool.
No problem.
Also, again, core assignments. Again, oops, sorry, I needed to change that. Let's put Sunday. This Sunday, 11:59 p.m. These are when these assignments are due. So please make sure these are your 3. I sent you an email yesterday. Really just want to make sure that all expectations are, super duper clear week 1. Great. Let me show this presentation again. Cool. Again, make sure you do have this passed. Really, again, by Wednesday morning. So our second class, I will say, make sure that you check these. So please make sure that that is there. If you do find yourself having to resubmit, there are either errors in your code or part of the assignments are missing or they're incorrect. It's okay. It's okay to resubmit a code. Or an assignment. It's okay to have to do that. That doesn't mean that you're not getting it. That doesn't mean that there's any frustration. If it seems like, oh, there might be a time that, we need to get together and do a one-on-one. If you're really struggling, that's the whole point behind the one-on-ones. So if you ever do get a resubmit, that is, don't take that as like, oh no, I'm not cut out for this. That's not true. I just want to make sure that you fully understand the assignment and do everything well. Cool. Any questions on assignments, expectations, any of that fun stuff? Hey, 11 minutes in, and then we're already jumping into code. Way better than 35 minutes yesterday. Okay. So what we're going to need and what we're going to move forward with and why, let's talk about Python, I guess. Python is one of the most popular languages out there. There's plenty of surveys out there. that ask developers, that ask data scientists, that ask people who deal with code what the most popular languages are. And Python always is in the top 3. It's usually JavaScript is up there for sort of web development because most of front end web development is in JavaScript. And then Python's really right there. And it's because Python can be an embedded system. So anything that's an IoT, or called Internet of Things, basically anything that connects to the internet, a smart light, an Alexa, any sort of thing that connects with the internet, that's called an embedded system. Whether it's web development, like Instagram is built on Python. There's tons of stuff. I think Google's primary language is Python. And then when you deal with what we're doing with data science and machine learning, Python's really the king. There is another language called R, but Python has sort of surpassed that in every facet of the imagination, because Python is so flexible and has so many things. And because of that, or with that, Python has a lot of built-in functions. So here we talked about functions yesterday, and here's just a list of built-in functions and what they do. This is what we call documentation. So when you are not understanding something, my first suggestion will say, read the documentation. If you don't quite understand, if the STR is not working the way that you feel like it should, or you're like, I'm sort of confused on why sorted didn't work, go in, read the documentation, because it says, okay, this is iterable, and it gives all the different pieces and how it works. And so getting used to reading and learning is going to be crucial to your success as a data scientist, because you're going to need to know certain things, because Python is great and has a lot of built-in functions, but what really makes it powerful is it has a lot of packages that is associated with it. And packages is going to be synonymous with libraries or modules. So you might hear it as a library, you might hear it as a module, but packages is really what makes Python so robust. There are packages to do mainly anything. If you wanted to scrape a website to get a bunch of data, there's packages for that. If you wanted to create a bot that speaks back to you, like a voice assistant, there's a package you can do that, and it's very quick. If you wanted to do some sort of computer vision machine learning, there's packages that are already built in Python that can, within an hour, you can spin something up. And that's why Python is so robust and popular, is because of the libraries, modules, and packages that come with it. Now, there's a ton. There are hundreds of packages and libraries. We're really going to right now deal with the 4 sort of big ones. Today, we're going to learn about NumPy. Next week is going to be pandas, the matplotlib, and Seaborn. These are going to be a lot of like data visualizations when we're making graphs and charts. But pandas is going to be how we are dealing with some large data sets and dealing with data frames. But NumPy, we're going to see today, is another crucial piece, especially when we're dealing with data, because it allows us to do things much faster and much more efficiently than maybe some of these native Python pieces. Cool. So that's going to transfer us over here. Now, before I get into NumPy, I do want to make sure we continue with these fundamentals. We talked a lot about lists yesterday. We talked a lot about tuples, a little bit less about tuples, but tuple is just a list, but it can't what? Does anybody remember what a tuple is? What was the big word I used?
Mutable or
Immutable.
immutable.
Yeah, immutable,
Immutable.
meaning that you can't change it, right? I can't change its values. Once it is declared, it can't change. A list is what we call mutable, meaning once I say a value right here, I've got this value called list, or I have this variable, sorry, called list var, and its value is 1, 4, cheese, and 19. But because it's a list, which is associated with these brackets right here, because of that, I can actually change these values where I can say list var. Does anybody remember how I would target the 19? What would I do here?
A 3 inside the bracket.
A 3. Why is it a 3? I count 4 things right here.
Because it's indexed to 0.
location.
Yeah, exactly. Remembering that our lists are indexed, meaning that they start at a number. So each value is associated to a number, but a list always starts at 0. So at position 0 is this value of 1. At position 1 is this value of 4. So that's how we wanted 19. It's 2, 3. So if I wanted to change that, let's say that I no longer wanted that to be 19. I wanted to be 34. I am now indexing and saying, okay, at position 3, which is our 19, of my list var, which is my list, I want that to equal 34. Then what I can do is I can say list var, and because this is the last thing in the cell, it's going to just show me what it is. And now you see it says 1 for cheese 34. We declare list var here. I target this last piece and it says 34. Does anybody know the other way I could get that last piece? It's kind of a trick.
Do -1.
Yeah, way to go, James. So if I would have said, well, I don't know who said it, but I saw James put that in the chat. So if I would have said list var, yep, -1 equals 35. I now, if I were to run this, you see it's 35. Just a little trick. If you say -1, that means the last one here. Just a little trick for you. Cool. So we've talked about that. So I have this list here, list var, and then I've got this dictionary, which we talked about dictionaries yesterday, remembering that they are a key value pair. So instead of having a index of 0, instead of it being numerically basically indexed, here it's by key name. So I've got, it's by keys, sorry. So this is what we call a key. Whatever's to the left of my semicolon is my key. Whatever's to the right is my value. Now I can have multiple data types. I can have a string, I can have a number, I can have a Boolean, I can have another dictionary or another list. We've seen that. We actually saw something fun yesterday in our office hour where if we sorted these, we recognized that capital letters, when we sort something, capital letters actually come before lowercase letters. If you want to know why, I can tell you in the next office hour. It has a whole big deal with how computers store that. But we saw these different things and how we can have a dictionary and same sort of thing. If I wanted to target my location, what would I put here? Anybody remember? If I wanted this value of where this location is.
Dict var and then location in square brackets.
Yeah. Would I do it like this?
Has to be in quotations.
Yeah, exactly. So here, if I say dict var location, it's going to give me the value that's associated with that key. So if I run this, cool. Now it gives me Seattle, Washington. Now, if I were to have, let's just a little bit of a recap. If I say address and actually say that it is a, let's say street. Number. How would I get this number piece right here? Anybody remember? If I wanted just the number.
Address in square brackets and then number in square brackets.
Yeah. Remembering that if I say this right here, what I get is another dictionary. So I can continue that same way and say number. Cool. Now it gives me this 6758. So I can go in and if it, let's say this number was another dictionary, I could continue doing that over and over and over and over again if needed. Any questions on this sort of little quick recap? Put a 1 in the chat if that all makes sense. Put a 0 or somewhere under 1 and lets me know there's a little bit of confusion and I can clarify. Okay, wonderful. Looks like that makes sense. If you do need more information, and always transparently, if you guys are not understanding, but everybody else is putting 1s, there's a chat feature where you can send it to everyone, or you can send it specifically to me. If you ever find yourself, everybody else is getting it, but you're not, feel free to put a 0 in what is confusing. And I won't say your name, but I will, I will go over that again. I'll just say somebody in here needed some help and clarification. So want to make sure that it's as open as possible. Cool. Now let's talk about lists or looping through. And this is what we call an iteration. So let's say I wanted to go through something. I wanted to say, I've got a list and I want every single piece here, right? I want to be able to grab and do something with every single value within my list. Well, sure, I could say print list var 0, print list var 1, print list var 2, print list var 3. I could do that, but that's not really going to make sense, right? Or that's not really efficient. Instead, Python has something called iterables or iterations, or for loops is what we would call them, for loops and while loops, that allow us to do something instead of saying print 01, print 02. I just write it one time and it does this code until some sort of condition is met. Somebody in the chat did ask, does it matter if it's single quote or double quote? It does not matter if it's a string. Both ones will work. I usually like to default to double quotes in case there's some sort of, like if this was a restaurant and it was like Will's Pub, if I do a single quote, it's going to mess it up. So just being aware of that, but no, it does not matter for string, single or double quote. So here's my loop. Let's say I wanted to loop through my list, right? Remembering that list var is right there. Let me close this and close this. List var is right here. It's 1, 4, now it's 30 or cheese and then 35. And I wanted to loop through that. What I can do is I can do something called a for loop. And for loop is saying, declaring a couple things. It's saying for, which tells Python, hey, we're about to loop through something. Then I have this, you can sort of think about it as like a temporary variable here, where item is going to represent each iteration I go through. So when I say for item in list var, what that's saying is I have this list right here of 1, 4, cheese, and 35. Remember, because we changed it. Item now represents, it's going to start at 0. It's going to start at index 0. So item is going to represent 1. And it's going to do whatever I tell it to do. In this case, I want it to print. So I just want it to print that value. It's going to say, okay, it prints it. Because all of the conditions for the for loop right here have been done, it goes up and it skips to the next index. So it starts at 0, then it goes to 1. Now item represents 4. It goes, it says, okay, what do you want me to do? It prints it. It says, okay, great. Then it goes to index 2, where it's cheese. What do you want me to do? Print it, and so on and so forth. And it does that over and over and over and over again until a condition is met. Now in Python, when I say list var, that is a short way of saying, I want you to go through my entire list. Go through the entire thing. So once this list is done, this for loop will stop running. So if I press this, now you can see it prints item, it prints 4, it prints cheese, and it prints 35. And that is located here on the, when we're dealing with for loops, that's here on this platform. If you are not, if there's not, this isn't clicking, it is here, right? I always like to also point out where something is on the platform because I think that's a great tool to have. And there are different ways that you can do that. You can do a for loop. If I'm dealing with a number, so let's say I'm dealing with a numerical value, I wanted to print all of the numbers between 1 and 10. I could use something called range, which is a built-in function specifically for numbers that I'm going to iterate through. In this case, we're just dealing with our list. It's not super necessary. So what we're doing with our list is fine, but just know that there are different ways to do a for loop. And it's also in the Python basics. There's a great section on for loops. I would really encourage you guys to look through that. Cool. Now, same thing happens with my dictionary. I can loop through a, there's quite a few things I can loop through. I can loop through a dictionary. I can loop through a tuple, a list. I can actually even loop through a string if I wanted. So if I, let's say, I'm going to put this here, loop through a string. This is just a unique thing about strings. So if I said strvr equals hello, and I say for, now this can change. I have item right here. It doesn't have to be item though. I just want to make sure. I usually like to use this because it is outrageous and it shows that it is not some sort of keyword. For unicorn in strvar, I want to print unicorn. So if I run this, you can see it says HELLO. A string acts the same way as a list. It has the index starts at 0, goes all the way through the end of the string. Just wanted to make sure you're not really going to do that a ton. But if you guys did need to do that, you can loop through a string the same way you do a list. A dictionary is a little bit different though. If I say for key, again, key is just any sort of value. I could say unicorn here, doesn't matter. For key in dict var, if I just say the dictionary name, oops, sorry, which is, I'm gonna close this right here, right? I've I've done this dictionary. I have this here. When I say for key in dict_var, if I just give the dictionary name, it's going to give me all of the keys. So if I run this, it gives me all the keys here. Let's say I wanted all the values. I could say dot values. And if I do this, it's going to take just the values of my dictionary and now gives me that back. So if I wanted to iterate through these values, I can either do dot values. I could do dot keys. That is available, but it doesn't necessarily make sense because dict_var by default, keys, sorry. By default, will do the keys. So you're running a function that is not really necessary, but you could do that. But let's say I wanted both, right? Let's say I wanted keys and values. Well, then I could do something called dot items. So with my dictionary, if I say my dictionary name, and then I add this method called dot items, and I will get both my keys and my values, knowing that the first value I pass here, again, it could be unicorn and cotton candy. First value I pass in here, this variable represents my key. The second one represents my value. Now, although it can be anything, I would really suggest for code's sake and for my sake, so I'm not trying to debug and you guys have like cotton candy and unicorn. And I'm like, what does that even mean? Try to be as descriptive as you can. Use key, use value, use item, stuff like that. But I just wanted to make sure that you guys were aware that you could do any sort of variable name if needed. You might see like an I, J if there's multiple. That's a really common thing, or K, V. But I would say be descriptive as much as you can. Any
So-
questions on for loops?
Yeah, for that loop where you're looping through key and value, and if you can use any variable like name, how does it know which variable is the key and which is the values?
So when you do dot items, you're going to have to pass in two right here,
Mm,
two values. And so it's automatically going to associate whatever, and it's separated by a comma, whatever you put as first. So if this was unicorn, it's going to say unicorn represents my
the
key.
keys.
Mhm.
Okay.
Yeah. Yeah, exactly. Great question. Anybody else have questions on loops? Makes sense? Cool. I do want to talk a little bit about functions because we're going to write a function today. So I want to make sure that you guys are aware and really see a function. And there's two things I wanted to represent and really speak on. A function is, and we talked about this yesterday, but it's a self-contained block of code. So if I know that a couple times I'm going to want to do the same thing over and over and over again, instead of me writing on line 100 to do this task and then writing on line 300, do the same exact thing, and it's the same block of code, there's a more effective way to do that. That's called writing a function. So basically it's a declaration of a code block that you only have to write one time, and anytime you need to use it, you can call that function name and it runs that same code. So it's an idea behind a dry code, meaning do not repeat yourself. So it's just this idea of, okay, if I can do this, let's say my function is 50 lines long. If I need to call that 4 times, I can shrink my code base, right? If it's 4 times, that's 200 lines of code. But if I just write it once, I shrink it by 175 lines of code, right? So by not doing the same thing over and over and over and over again. There are functions that we're inherently using. When I say print, that is a function in Python, sort of similar to what I showed with these built-in functions, right? These are just code blocks that have already been built by the creators of Python that when I run map, it does some code base. It does something to my code. It might have some parameters, it might have some rules basically, but these are built-in functions in the language of Python. I can use built-in functions like my type or my print. We talked type yesterday, shows the type of a variable, or I can actually build my own. Here I've got a function just called sum function, right? That is my function name. The way I'm telling Python I am declaring a new function is def, declare function, right? I'm telling Python, all right, I'm going to make a new function. I want you to save that as a function. And anytime I call that, this is what I'm calling. So I have this, I say def that declares my function. I give it some function name. This can be anything. Don't have spaces or anything like that. Make sure you use snake case. but it can be sort of any name. And then if you need some sort of value in order for your function to run, then that's what we call a parameter, right? Or an argument, meaning you have to give me, in order for this function to run, you have to give me some values. So for instance, let's say we're doing a for loop and I wanted to create a function that iterated through a list. Well, in order for my function to run, I need to have a list, right? You have to give me a list in order for this to work, or else this function is pointless. So I might say something like, listy or X, meaning whenever somebody wants to run this function to iterate through, they can call the function, but they have to give me the list that they want to iterate through. Does that make sense? This parameter / argument. Just call it an argument. Does that make sense? Any questions there? Can you put a 1 in the chat if that makes sense? Cool. Great. Now, then after I put my semicolon, and then I do what we call a code block, where it has to be indented under my function. So whatever is indented under my function is how Python knows this code is associated to this function. Once the indentation is done, once something else is on the next line like this, it says, okay, this, some code, this has nothing to do with my function because it's not indented. That's called a code block with Python. So Python doesn't have curly brackets or anything. It just has the semicolon and then indentation, which says this belongs to my function. So let's look at that, what that means right here. My function, sorry, that slash didn't mean anything, Edwin. That was a typo. I have fat fingers. Okay. So here I have this function, and there's two pieces of the function that we need to sort of, I know I've said the word function a whole lot, and I'm sure that's probably annoying, but here we go. There's two things that we can do, or there's a million things we can do within a function, but two that you might initially start to see. First one is print. And again, that is a built-in method in Python that allows me to print and see something. So if I run this, it says hello world, right? I printed that. That's something for me to see. Now, when I run print, it shows me something. If I'm dealing with code, it might show me something, but if it doesn't equate to anything within my function. Sure, I see it when I run this function, but it doesn't do anything. It just prints and that's it, right? There's another thing within a function called return. What return does is if I were to say something like this, I've got this def return func, and what it does is it returns hello world. What that means is if I were to say X equals return func, what happens is the code says, okay, I'm declaring a new variable. It's equal to, and then I give it this function that says, oh, I need to go run whatever this function is. So once it runs it, whatever is returned from a function is what the value becomes. What do I mean by that? So if I were to print X, I'm declaring X is equal to whatever this function becomes or is returned from this function. Well, what's returned is hello world. So if I say print X, you're going to see the word hello world. If I were to say return 3 plus 6, and I run this, you'll see 9. It will do some arithmetic in there, but anything when I see a return, that means that is what the value of my function call becomes. Again, print is great for us when we're trying to see what, visually trying to see something. Doesn't do anything necessarily from a code perspective. But if I have some function, if I wanted to say 5, I could do that and it gives me 14 because this returns 9. That's the value that it becomes. Then I add 5 and that equals 14. Any questions on print versus return? Does that make sense? Now, the last thing I just want to really touch on just very, very quickly is slicing and indexing. We sort of talked about this where if I wanted to associate a value or if I wanted to grab a item from a list, I can do that by the index of where it's at. Again, starting at 0, going all the way up to however large the list is. And the little trick that we saw, if I have a -1, that gives me the last item from my list. And then lastly, if I want to get a value at some key, I just say the dictionary name, and then I give the key, and then it gives me back that value. Any questions with slicing and indexing?
Sorry, Will, could you just repeat that really quick?
Yeah. So this list var, I'm saying I want to grab the first item starting at 0, right? I have my list var, which is up here. This guy. Remember, this is at index 0, 1, 2, oops, sorry, 2, and 3. If I just want to get this first piece, if I want to get the first one, I can say list of 0. And that's going to give me the number 1. If I want the last value in a list, I can say list var -1, which is 35, which, because we changed our list right here, remember we said -1 is 35. That is our last value. Like if I were to run, I just want to show you that they're both the same. Var of 3, which is my last one here. It's 35, right? So if I wanted to do that, I totally can. That's my last one. If I want to do the second one, I would put 1 and 2, et cetera, et cetera.
Got it. Thank you.
So Tanner asked a great question. Could return be used for like if then equals a return response? Yeah, so there's conditional statements within Python. That is like an if or a then. So basically like if this is even, then I want you to do this, else I want you to do something else. It's an if, elif, and else, which, let's see, I don't know that you need, oh yeah, Booleans and conditional logic right here. Great question. So with conditional logic, that is our if, elif, and else. So what that is if I say if, then Python is going to compare multiple things. So in this case, I'm just going to actually copy this and let's go into the code base. So here my number equals 10, right? I have this value, I have this variable called num, and it's equal to the value of 10. What this does is it says if, and then what I'm going to do after an if is I have a comparison. Here I'm saying num modulus 5, which we'll get into that in just a second, but I'm just going to say num. We'll get to that other one in a second. So if num equals 0, saying if the value of num compared to this value, if those are true, then I want you to print buzz. Else, print fizz. So what this does is it prints fizz, right? Because, and we see this on the platform, what it does is it evaluates and says 1 + 1 = true plus true. Those are true. These comparisons saying, is this equal to the other? Is what is on the left, num, which we know is 10. Does 10 equal 0? Well, no, right? If it does, right? If this equates to true, then do whatever is in this code block. This else is saying, you know, okay, if this wasn't fulfilled, then go ahead and do this. Now I could have another one. I just think this is important for you guys to know. So if I say elif num equals or is less than, let's say 11, then I want to print less than. What it does is it says, oh, I put greater than, my bad. I was like, why did that not work? So what it does is it says, okay, I've started this conditional statement, an if, elif, and else is what we call a conditional statement. And it's going to start from the bottom and then go line by line. So it's going to say if num equals 0. Does 10 equal 0? No, it doesn't. So it skips this, right? It doesn't do whatever's in this code block. It goes to the next one. It says, or if number is less than 11. Okay. That is true. That condition is true. 10 is less than 11. So then it goes into this code block and does whatever. Now, one thing to note, especially when we get to this FizzBuzz assignment, if I were to say num equals 10, print equals 10. Both of these are true, right? Num is less than 11 and num equals 10. What do you guys think is going to happen right here? Anybody have any guesses?
They'll just print less than,
Yeah, why?
because it's gonna stop on that first condition because it's the conditions that's first true, or that's true first. So it won't keep running if that's the one that's true. So order matters with the loops.
Exactly, Amanda. If I run this, it's just going to stop at less than because a conditional statement continues to run until it finds a true statement or it hits an else, right? If none of these are true and then it hits else, it's done running. So it does matter from a position. If you're dealing with the FizzBuzz assignment, 15 is both 3 and 5, right? And so if you have 3 or 5 above the most, sort of stringent condition, you're never going to get FizzBuzz. And so that's why with this approach, we put this piece here above, because we want to make sure we know that if this is true, both of these are also true, but this does not have to be true for this to be true, right? So therefore, condition or order does matter in regards to our conditional statements. Any questions on conditional statements?
So kind of, I guess for me to like piggyback off of, I think it's Tanner that asked the question. So then if you were going to try to do a return, how would it work with the if else statement? Because it's not really a function, right? So what are you going to set the return to?
You can just have multiple returns. So you can say, you're saying, if this is true, I want you to return less than. If this is true, I want you to return equals 10. Now, noting that anytime a function sees a return, the function stops running and just returns that value. So even if I have a function that is 45 lines and the first line is return hello world, it's going to negate the 44 lines. It doesn't even matter. And then just moves forward. So anytime a function sees the return, it stops running. So if I were to say print hello there, if I run this, it doesn't print that, right? Because it doesn't ever get to this line, because once the return hits, this function's done running. So yeah, you could have a conditional of, hey, if this is the case, I want you to return. That's really popular with like web development. So we're saying like, hey, if they're not logged in, so, most pages, if they're not already logged in for like Facebook, let's say, if you're not logged in, you can't see marketplace or you can't see certain things. So a conditional statement is usually the beginning of return them to this other page. Hey, please log in before you do anything. Any questions on functions and conditional statements? I'm glad that you brought that up. Thanks, Tanner. Does it make sense? Could you guys put a 1 if this makes sense? 0 if it doesn't? Cool. Okay. So now is when we're diving in for the next 15 minutes, 20 minutes, maybe. We're going to dive into some NumPy. And we're really going to start seeing how we can use these built-in packages or modules or libraries. I will probably call them a library more than anything. That's kind of synonymous with one another. But just know that there are plenty of things that Python has that you can install. Now, the reason we use Google Colab is because it has tons of stuff built in. Like if we wanted to see all of it, I could say pip, I think freeze, pip freeze. Let's see. Yeah. So if I say pip freeze, pip is just a way that if I was going to install something on my local computer, I can do that. But if I do pip freeze, it shows me everything that is included when we are using our, when we're using Google Colab. All of these packages come already pre-built, already on there, things that we will never use and things that are there like lunar calendar. If I wanted to deal with that, I could do something with the lunar calendar, Korean lunar calendar. All of these things are already built into Google Colab. That's why we use it. Now, if you were going to do something on your own that wasn't in Google Colab, you would have to download every single package that we're dealing with. You'd have to do something. There's different ways to do it, create an environment that have certain things, but we don't have to do that because Google Colab has all of that fun stuff for us. Cool. If I ever did want to install something that Google Colab doesn't have, I would do this exclamation point pip, and I would say install, and then whatever the package name that I want to install. So if there is something that you personally want to do for like your second project, and there's a package you want to use, you would say pip install. But you would have to have the exclamation point that tells Google Colab that you're sort of you're going to install something just like you would in your command line. And then you would say, you know, some package right there. And then it will install that package and all of its dependencies that are needed. Cool. Any questions on that so far? So once we have that downloaded and we have access, which Google Colab we do, we can't just like instantly start using it. We also have to import it. So the way that we import a package is we say import and then the package name. Now, when we're dealing with NumPy, we can call it NumPy. So I can say import NumPy, but what's really well known sort of in the industry is sort of everybody got together and said, hey, writing NumPy a million times, not as fun. Let's just call it NP. So if you see it as NP, that represents NumPy. And if I ever want to change the name of my, package to sort of shorten it, I can say import the package. When I say as, this as means that I'm going to import it. And then what do I want to represent that package? Again, in this case is NP. This could be unicorn. This could be cupcake. It could be whatever you want. I would say get used to, we're going to do like PD for pandas and NP for NumPy. Get used to doing these sort of industry standard stuff. I wouldn't go out and call this unicorn, right? That's just not what I would do. But you can import packages and you can change the name there. So if you do have some random package and you wanted to call it something super, 2 letters or something like that, that helps you, you can do that. The reason we're going to deal with NumPy and where it really comes in handy is we've seen what we can do with lists, right? And what we can do with tuples and what we can do with dictionaries. But when we're starting to deal with much, much larger data sets, that stuff's just not really going to work. The built-in sort of native Python data structures and functionalities aren't going to be as optimal for us when we want to do, and we're going to see an example in just a second, where if I wanted to multiply 2 lists together, I can't do that. That's where NumPy is going to come in. That's where this package is really going to be efficient. If I wanted to multiply 2 lists together, I would have to iterate through each list, take those values, multiply it. It's a whole large thing. And it's not efficient when we're running, when we're actually running our code. It's not efficient, not near as efficient as using something like a package like NumPy. So first, let's go ahead and import NumPy. Cool, did that. When I say NumPy, right, again, remembering that Google Colab shows the last thing that you say, it shows us that it's a module, and it shows us sort of where it's located from a Google Colab perspective, and we called it NumPy. Now, again, we're going to use NP, so let's go ahead and do that. Again, if I say NP, you see the same thing because NP just represents NumPy. Any questions on importing a package at all? I mean,
So is this,
go ahead.
sorry, go ahead.
No, go ahead.
Okay. So is this how you would, so Colab already has NumPy installed, right? But you still have to import it. Is that?
Yeah. Yeah. So you
So-
still have to import it because let's think about it. If we had all of these packages on every assignment, even things we saw, like there was a music one and a lunar calendar one. If we had all of those, it's actually going to be really bloating for our code, right? Really bloat our actual application. So what it does is it has access to them. I just have to say, I just want to use this piece. I just want to
Got
use NumPy. Great question. Cool. Any other questions there? Now just know that there are other functions and classes stored in the package that we can do with what we call dot indexing. So here I have NP array. That is a function within NumPy that I can use. So this dot array is now using this function or calling this function within my, my package or my library that I bring in. So libraries do have functions. That's why I was talking about documentation is really going to come in handy, and knowing the power of NumPy is by knowing their built-in functionality within NumPy. Cool. There are also what we call sub-modules. So a package actually can be made of smaller pieces called sub-modules, which allow functions to sort of be organized in a helpful way. So NumPy, for example, has a sub-module called random. And random itself contains functions related to generating and selecting data based on a random chance. So in the same way, we just talked about how NP NumPy has this function array. It also has sub-modules. So if I say np.random.choice, that is a function within my sub-module of random that exists within my module of NumPy. Does that make sense? So if I were to say something like this, and it's not just choice, if I say random dot, it brings up all these different things, all these different functions that I can use. All these different pieces. Oops. So let's say that I didn't know what to choose for dinner, and I had this list right here of cheeseburger, chicken tikka masala, lasagna, and filet mignon. I could say, I just want to use this to generate a random choice. So if I run this, you can see it says lasagna. If I run this again, it says filet mignon. This is just picking at random a value within this NumPy array. I'm gonna do this. Again, this is a submodule. Submodules have their own functions. So we're going from our module into a submodule, into that submodule's function, and it runs that code. Any questions on that? No, it's a little heady. Yeah, go ahead, Benjamin.
Can we import just a submodule if we only need the functions in it, or do we have to import the entire thing?
Great question. I think you can just do a submodule if you did need. So if you just were using random, we won't. So we are going to use NumPy. We're going to use different pieces of NumPy, but yeah, you can sort of go more into that as well. Any other questions? Great question though, Benjamin. Cool. So you might ask, okay, this makes sense, but why are we dealing with NumPy? And again, it's because lists and tuples are not really efficient when we're dealing with large amounts of data. So with NumPy, it does have some linear algebra, right? That has a lot of mathematical manipulations that we can use. So an example would be, let's say that I am dealing with this piece right here where I've got a calories per serving list with calories per serving, right? And I want to know if I were to eat a certain amount, I want to see how many calories there are in the total list right here. Well, I can't just multiply a list times a list. I can't do that. So that's where NumPy is really going to come in handy. So let's see what this is asking us to do. So it says make a calories per serving array, or again, array and list are going to be synonymous here. An NP, NumPy calls it an array, but obviously it's called a list in Python. So it is going to be the same thing. So what I want to do here is I want to make an array with all the calories in, oh, I don't want to do that. All the calories here. So what I'm going to say is calories, I called it calories per serving. That's going to be equal to, now I could do, this is my list, right? And if you think about it, if I'm looking at this, I would say 740, 240, 408, and 301. But when I'm doing this, again, I can't multiply a list times a list. Let's say I had some like quantities. And that equaled, let's say 1, 2, 3, 4. I can't multiply if I were to say something, and you're going to deal with this when we're getting to your assignments. I can't say like calories per serving times quantities. Because what I wanted to do is I want to say if I eat one cheeseburger, I want this, how many calories that is. If I eat 2 chicken tikka masala, I want to know how many calories. If I do this, I'm going to get an error. That's because my list cannot do these comparisons, right? It cannot multiply this, but we need it to. And again, that's where NumPy comes in. So what I can do instead is I can say, I have my list here. I can say NP, because we brought it in as that array. And when I say NumPy array, and then I call calories per serving. Cool. Now you see that I've got this array that's 740, 240, 408, and 301. Okay, that's fine. But as we continue forward, let's say I want to see what is the price of these different things, or I wanted to see a total price. We're going to go, I have 4 questions here. We're going to go through this first one together. But okay, let's set this up. We've now made this as a NumPy array. Let's go ahead and do the same thing. I want to make a prices. So I'm going to say prices. And that's going to be an np.array. And we're just setting up our assignment right now. I got 8.5. I think it's 11, 12.5. And then what's the last one? 15.75. Oh, let's go off. 12.5. I've got 11. And it's going to be 15.75. Cool. So I've set this up. And if I say prices, I want to see this, make sure everything's good to go. Cool. 8.5, 12.5, 11.0. Notice it made it a float, and then 15.75. Okay. I'm actually going to skip this enumerate piece. We'll get, if we can, here in a second, we'll get to that. And then this function piece. But okay, so we've got this prices, and I've got my calories per serving. So here it says, what would our total calories be if we ate 2 servings of lasagna as a class? We go out and have lunch. We're having 2 servings of lasagna, 1 filet mignon, and 3 cheeseburgers. So what I'm wanting to see is, what is my total calories made here, right? What is my total calories consumed? Well, I'm going to need to create a quantities, right? I need to create different quantities for what we've eaten. So I'm going to say something like servings. Again, I'm going to make it an NP array because we're going to do some math associated. I promise it's going to make sense here in just a second. Where, okay, I said it's 2 servings of lasagna. Now, if I come up here, I see lasagna is the 3rd one. So, okay, I'm going to have, let's see, we said 2 of lasagna, 1 of filet mignon, 3 cheeseburgers. Cheeseburgers is first. Tikka masala is not there. 2, 1. Okay. So I said servings equals 3, because remember, cheeseburger is associated to this first piece. We've got 0 tikka masala. I've got 2 lasagna and 1 filet mignon. So if I say servings here, you guys see what I mean by this first position is cheeseburgers, and this first position is cheeseburgers? Does it make sense? That's where this enumerate was going to come in, but I'm a little bit low on time, so I want to make sure that we get to this NumPy piece because that's the most important for your assignments. Okay, so if I've got that value, I've got my servings, right? And I have my calories associated to each one, my calories per serving. Now, because I've made it a NumPy array, instead of having to for loop and do this through a for loop and take the values and then multiply it, I can actually just do something like this. I can say servings times calories per serving. Now, because I want the sum of this, I just want the total calories. Actually, before we do that, let's just see. Oops. Run this. So now I see this array, right? Where it actually multiplied 3 cheeseburgers by whatever calories that was is 2,220. I didn't have any chicken tikka masala, so therefore there's 0 calories associated. I had 2 lasagna, so 816, and then 1 filet mignon is 300. So now you see that with a NumPy array, I can actually multiply the two together. I multiplied this 3 by the calories per serving, and so it took these lists and multiplied them together. Now, if I did want the sum, I could do something like this. I wanted the total calories. That's what it was asking me. So I say sum. Then it just gives me the total value here. Could also say does the same thing. So NP sum allows me to do that, or I could just do dot sum, and that's built in, and then it shows those values. Does that make sense on why we would use a NumPy array?
Will, did you have to define calories per serving there? I didn't see you do that.
I did. So up here, I have calories per serving, where I defined this data basically. So I make this
Oh,
array
okay.
of
There it is.
740, 240, 408, 301. So then now that is what that value is.
Got it.
And then I have a price too. So we're dealing with price. Now there's a price associated with each. So if I want to know the total bill. So actually, let's just do this next one together. What would our total bill be? How would I do that? So we've got, so far, we've got our, I'm gonna use this. Just close that way, it's easier. I've got my calories per serving, my prices. And then I've got my servings. If I want to calculate the total bill, what do you guys think I would do here?
The array of servings times the prices.
Yeah, tell me exactly what to write, piece by piece. I'm gonna be a robot. You guys just tell me exactly what to write.
So would that be np.sum prices times servings or whatever we have it labeled as?
Yeah, exactly. Prices times servings. Exactly. So our bill is 63.25. What's the other way instead of doing np.sum? What's the other way I could do it?
Just dot sum at the end.
Dot sum. Yep, I'm calling the sum function. It's taking those values, summing them up, 63.25. So by converting this list to an NP, a NumPy array, it allows me to do some sort of multiplication or some sort of arithmetic with them together. Again, if I were doing a normal list, I would have to iterate through it, I'd have to for loop and do some sort of thing. And it's going to be way less efficient than using something like a NumPy array. There was a question. Was there a question? I thought I heard somebody speak.
Oh, yeah, it's probably stupid, but when you put
Oh.
dot sum at the end and then the parentheses right there at the back of it, is that parentheses just basically calling out what's in the parentheses previous to the dot sum?
No, great
Or-
question. When I am calling a function, so remember if we go up here, that's not a dumb question by any stretch of the imagination. If I go all the way up to my functions, this is a great thing I didn't cover. A function's great and it has code, right? It's good, but it doesn't ever run until it is called. So here I have this function of print func, but I have to then call that function. But I have to say the function name and then I have to give the parentheses. By doing that, it actually calls in what we call invoking the function, and it tells Python, I want you to go to the function of print func and then do what it says. So what that's doing, the sum piece, is it is a built-in function. Is it saying, okay, I have these values. Now I want to run this function and sum them up together. So these parentheses is what is invoking my function. It's my function name, and then the parentheses invokes my function. Great question.
But could you have more than, like, can dot sum be, like, say if you have multiple arrays and, or say you have prices and servings and calories and servings, and say calories and servings is in brackets. Could I put dot sum brackets and then I would get the sum for what's in the brackets versus what's in the parentheses? Would it leave the parentheses
No,
alone?
sorry, the parentheses here, anything that's the dot is going to be associated to what it's connected to. It's called a chaining method. So it's connected here to prices and serving. So it's going to take the sum of whatever it's connected to.
Okay, so I couldn't have dot sum like somewhere later in my coding and have it go back to.
Mm-mm.
So-
Unless you
okay.
had, yeah, unless you built a function that did that, that called that, and then you called that function. No, yeah. It's got to be associated to something. Great questions. Any other questions on this? Anything that needs clarity? We're gonna actually break into groups for this next 25 minutes. If you guys can, obviously class, the attendance piece is done, but I would really encourage you guys and myself and any TAs that are still in here are gonna hop around. And I want you guys to do these next two. The whole point too is we're gonna get used to doing stuff together as a class. Towards the end, we're gonna be able to walk through some code and have some different pieces. So I want to make sure you guys are familiar and aware of communicating and sharing your screen. If you guys, so whenever I put you in breakout rooms, I do want you to sort of test that out. If you guys do try to share your screen and it says that you need permissions, you will have to leave the Zoom and come back, but that's just something to be aware of. I'll still add you back into that room, but just to kind of get us prepared, because this is a big part of, you know, this program is we teach and then you guys go and do something and then we come to help as well. So please negate this run our function piece because I didn't write that.
Hey, Will, we are over time, so technically people, if you have something you need to go get somewhere, you're not required to stay past time, but definitely you should.
Yeah. Yeah. And that's what I was saying, that if you can stay here, but the attendance piece is fulfilled. Yeah. Thanks, Mandy. Yeah, I would encourage you guys to do that. So any questions on anything I've covered tonight? I do want to point out as well, there is going to be an assignment. I do like to sort of make sure you guys have everything you need for all assignments. The only one is going to be this project part 1 core. And the thing that we haven't gone over, we're going to go over it next week when we're dealing with pandas, is how to load in data. The reason I'm not going over it is because I want you guys to try it. And the other piece is because there's a great portion right before the core assignment called load data. That is a walkthrough piece by piece. We're going to import pandas the same way we do as NumPy, just we're going to do it as NP. And we're going to have, it has a step-by-step way of how to import your data, mount your data. So I want you guys to try it. We're going to go over it next week, but that's the only piece that we haven't necessarily gone over. If you guys really need help, obviously any sort of TA can help you, but there's a walkthrough, a sort of step-by-step walkthrough of how you would mount it. We are going to go over it on Monday, but just wanted you guys to be aware of that. That is located in the load data section, and that's what you will need for project part 1. Other than that, distance and time is NumPy array stuff. Dealing with that, having to manipulate some sort of data. Same thing with bakery, NumPy. We tried today, example, tried to sort of help with the bakery piece. Any other questions? Anything at all, friends?
So for this week, I know the goal is from the last lecture is basically have these 3 things completed by Friday. Obviously end goal Sunday midnight. But those are the 3 assignments and that's it.
Yes.
For this week.
Yeah.
Okay.
The 3 assignments are going to be your project 1, part 1, your bakery, NumPy, anything that says core for this week 1, which is your bakery, your project 1, and your distance and time. Those are your 3 ones. 3 core assignments that are due. Again, try to do it by Friday. So that way this weekend you can start next week, but worst case scenario, they are due at 11:59 p.m. on Sunday. And that's
I have a
Pacific Standard Time. Yeah, go
I have a
ahead.
question, Will. So solutions, because I do have to run real quick, but
Yeah.
would solutions to these questions like potentially be posted somewhere that we could like check it if we do try it ourselves?
Yeah,
Or
I'm happy to do that. I have the solutions page. Absolutely. I'm happy to do that.
oh, cool, awesome, thank you.
Absolutely. Great question. And then on that solution page, there is some different things for enumerate and a key way of why enumerate would be a good idea and how we can use that. and then just maybe creating a function instead of maybe, I had to go up and down of, which cheeseburger was first or second. Creating a function that would help that is going to be in the solutions as well. So any other questions, friends? Cool. Well, I'm gonna stop the recording here.